Hi, welcome back to My Tech Notes, your channel for breaking down AI and tech concepts in a simple and practical way. If you're new here, make sure to subscribe for clear explanations on generative AI, machine learning, and modern tech. Now, let's start today's video. Have you ever wondered how models like ChatGPT understand the order of words in a sentence? For example, dog bites man and man bites dog. Same words, very different meaning. So, how does generative AI understand this difference? The answer is positional encoding. In this video, I'll explain positional encoding in simple terms, why it's needed, and how it works inside Transformers and the backbone of modern generative AI. Let's get started. Transformers don't read text, humans do. They don't process words one by one from left to right. Instead, they process all words at the same time or in parallel. That makes them extremely powerful. But it also creates a big problem. If the model only sees words and not their order, then word sequence is lost. So, to a transformer, without positional encoding, I love AI, and AI love I look almost the same. That's obviously a problem. And this is exactly why positional encoding is needed. Before positional encoding, text is first broken into tokens. Each token is then converted into a numerical vector called a word embedding. Embeddings represent meaning. They tell the model what a word is about. But embeddings alone do not tell the model where the word appears in the sentence. So meaning is present, but position is missing. Positional encoding solves this problem. It is a vector that represents the position of a word in a sequence. Each position, first word, second word, third word, gets a unique positional vector. This positional vector is then added to the word embedding. So the final input becomes word embedding plus positional encoding. Now the transformer knows what the word means and where it appears. In the original transformer model, positional encoding is created using sine and cosine functions. Why sine and cosine? Because they form smooth repeating patterns. These patterns help the model generalize to longer sentences than it has seen during training. Each dimension of the positional vector uses a sine or cosine wave with a different frequency. This allows the model to understand relative positions. In simple terms, the model can learn how far apart words are from each other. You don't need to memorize the math, though just remember the idea. Patterns encode position. Modern models often use learned positional encodings instead. Here, position vectors are learned during training, just like word embeddings. Some models use fixed encodings. Some use learned ones. But the goal is always the same. Give transformers a sense of order. So let's quickly summarize. Transformers don't understand word order. Positional encoding injects position information into word embeddings. Without positional encoding, generative AI wouldn't be able to write meaningful text, generate code, or hold